Hi, I'm John Paulraj, and this is part 12 of the Complete Solutions series for May 2025 IB Math AI HL Paper 1 Time Zone 1. Let's roll the intro. So here's a question. This is question number 12. It says the following graph shows the slope field for the differential equation. That's the differential equation given to you, and the graph, they've given you a little grid with the graph showing the slope field dy by dx is equal to x to the power 4 plus 4x squared y plus 4y squared. And that's the slope field contained between, be very careful when you're looking at the slope field, basically, and you're looking at these points. So this is a negative 2 here, and I think this is a negative 2.5. Okay, look at the scale. I think that's one thing to keep in mind. Okay, where is this slope field? You know, what is the, sort of to say, the window settings, the x minimum and the y minimum. I think that's the first thing to look at. Okay, so the x min value is negative 2.5 to the x max value is 2.5, and likewise I think the y min and y max is also something similar. So it's is it 2.5? It looks like negative 2.5, and then it goes all the way till 1.5 only. Okay, it helps. I'll tell you why it helps. So keep an eye on the graph. Okay, so this is the graph, and it shows you the slope fields, only the tangents at the different points. Okay, at the different points. Some of the points actually on the grid will cross, and those are, I would call, the nice points. What I mean by nice points, let's just take a look at one of them. Okay, so I guess you know, if look at this one, can you see this one? That's a nice point. You know what I mean by nice? It means it actually crosses that, you know, that grid. It's a nice point. Even when you have a normal grid, you know, when you have a curve that goes through that, you know, the crossing of both the final lines, you know, the, what do you call it, crosswise or something like that, it's easier to read that point than to estimate. And that's why I said it's, you know, some of these tangents, because those are the slopes, right? Those are indicating the slopes. Some of the tangents to the various solutions are easy to read off when you are able to see whether it's crossing. Okay, whether it's crossing. So that's something that to keep in mind. Okay, let's just go to the first question. On the slope field, sketch the solution, a particular solution to the differential equation that passes through that particular point, 0, 1. So I think the first thing to do is also to mark where that point is on the slope field, 0, 1. Obviously this x coordinate is 0, y coordinate is 1, there. Okay, that's the point. So mark that point, and then you got to mark the solution that goes through that point. Okay, that goes through. Okay, so it definitely has to go through that point. Okay, it's just 2 points for this particular question. So let me just try whether I can get this in one hand. I'm going to use the green color, and so through this point, okay, something like that, and like so, and is it cutting too early? Yeah, I think it is cutting. Maybe it can cut. Give me a second. Maybe it can cut a little. So if I have, you know, something like that, yeah, I think that's a better curve. And you can even indicate this x-intercept. Okay, so we'll come to that in a bit. And once it comes through there, I think your slope field looks nice. I think it can go down here. Oops, I thought so too. Okay, so I think that's good. That's a good solution curve. I hope you can see this thing, what I did. All right, so this particular point is what's given. It's 0, 1. You don't have to mention that on the exam. Okay, that's just for you to know. All right, so this one is that point, and this point obviously is important. Okay, so you can make sure that point is given. It's something like what is this? 1, 2, 3, 4, 5, 6, 7, 8. So maybe something like 0.9, negative 0.9. Okay, so that's the x-intercept. So make sure you can even write down the x-intercept for that particular solution curve is negative 0.9, and of course the y value is 0. Okay, you can mention that also because it's going through that, right? Okay, the next one. Some of the solutions to the differential equation have a point at which the gradient is 0. Gradient is 0 means dy by dx is equal to 0. Okay, this dy by dx which they have given you. Okay, dy by dx is equal to 0. In fact, that x-intercept also means for the curve, x-intercept for the curve. Okay, this is the curve. That is not the same thing as dy by dx is equal to 0. That is where the y is equal to 0. Okay, so understand the solution is y, but dy by dx is equal to 0, where are they saying? Some of the solutions to the differential equation have a point at which the gradient is 0, have a point. Some solutions have a point. This particular solution probably does not. Okay, so this is green is one solution to the, to that differential equation. It passes through point 0,1, but dy by dx is equal to 0 is where there's a horizontal tangent. So if you actually try and zoom in, physical paper, you'll not be able to zoom in. Okay, I understand. But if you're able to look at it very clearly, these are the points. Can you see here? There's the horizontal tangent. There's a horizontal tangent. Can you see that? That's a little up. I won't call that a horizontal tangent. Maybe these two are horizontal tangents. This one looks horizontal. Okay, you can look at that. Okay, this is not quite horizontal. Okay, so pay attention. Okay, we are talking dy by dx is equal to 0. Where else do you see? If you scan through, you will see that there are some horizontal tangents here. Can you see that point? That one? Okay, that one looks like a horizontal tangent. That one just looks like a horizontal tangent. That one definitely looks like a horizontal tangent. Likewise on the left hand side, you can see that. So basically, I'm saying that, where you see those tangents, the slope field is all, the slopes of the tangent, right? So wherever you see a horizontal tangent, those are the points we're looking for. So what is the question? What is it saying? It's saying some of the solutions to the differential equation have a point. There might be one point, there might be more than one point, I don't know, there might be a point at which the gradient is 0. That means dy by dx is equal to 0. That means there's a horizontal tangent. The curve on which all these points lie is given by the equation. So there's another curve, y equals ax squared. I hope you can see this, where a is to be found out, a is a constant to be found out. The curve y equals x squared contains all these kind of points. What kind of points? Where the gradient of the tangent is equal to 0. The gradient is equal to 0 means the gradient of the tangent is equal to 0. Okay, so sketch that curve. Sketch the curve on this same slope field. So since I marked it with pink, let me try and draw that with pink. Okay, so as I said, I've marked certain points here. So let me just make an attempt to that. Okay, so horizontal tangents, keeping an eye on that. So definitely at 0, 0, and give me a second. Maybe I just that's a little too wide. So if I follow the path, there's a trick to drawing these. What do you call it? Give me a second. I will make it pass through this one, and there. Okay, and then it's a clear reflection of that. So it goes through, as you can see, -2 and -2. Okay, so obviously you can go further down also. Okay, so on this side it goes to -2, 2. That's the point, -2, 2. Okay, so then obviously it has to be symmetric, and let me get that right. If it's -2, 2 here, then obviously the point out here must be something like 2, -2. Yeah, there you go. You can see that horizontal tangent there also. So let me just see whether I can get that thing right. So it has to go through this path. Yeah, I am not very good when it comes to sketching. Not an artist, as you can tell by now. But that doesn't mean that we should not draw. Okay, so ignoring all my shortcomings, I have drawn the curve. Maybe I can give it another go because it has to go through that point. Okay, let me try it again. So here we go. Yeah, that's the best I can do. Practice the sketching. Okay, even though you might not be good at art, you can see that I'm not good at sketching at all. But at least the point of in the math course is not to be artistic, super artistic. Make it as accurate as you can. Okay, at least show that working. And while we are at it, sometimes children don't have enough practice for slope fields. I think you can even use your calculator. Although this is not a calculator question, I'm just going to quickly show, because in my answers here I'm just showing you the tips. This is not a calculator, is it? No, it's not. Part C. I'll share the tip later. Okay, let me see how I'm doing with time, and then I'll share the tip later. Okay, let's move to part C. So I hope that is clear. The sketch to that curve is done. So part B is done. C part says use the differential equation to find the value of A. Use the differential. That's the differential equation we want to use. Okay, dy by dx is equal to. Okay, and what do we know? What do we know about this solution? They say this curve that we've just found, the pink one. The pink one has the form y is equal to ax squared. Okay, and it goes through the points where dy by dx is equal to 0. Remember I said that. Okay, so we will use that condition that dy by dx is equal to 0. Here there's space finally. So this is, I think, number 12 part C, is it? Yeah, 12 part C. 12 part C. And what do I have? I have dy by dx is equal to x to the power of 4. Let me write down dy by dx equals x to the power of 4. My x looks funny today. Actually looks funny every day, some might say. Plus 4x square y plus a 4x square y and plus a 4y square plus a 4y square. All right, so now we have dy by dx is equal to 0. So we say 0 equals x to the power of 4 plus a 4x square y plus a 4y square. Understand why we took that as 0, okay? I hope that is clear, because that goes through the points where dy by dx is equal to 0. As it said, the gradient is 0, right? In the question it says the gradient is 0. So we're using that condition. Right hand side, how do we do? There are a couple of ways to do this. You could actually even substitute y is equal to ax square, make everything in terms of x, and then solve for that. I see the easiest way is, just complete the square. It looks like a perfect square again. Yeah, it looks like a perfect square with the right hand side. This is x square plus 2y. I think so. Yeah, that's right. Now, that's another bit of algebra because this is an AI paper. Yeah, I'll just make sure that I write down the formula. We're looking at the perfect square, a plus b the whole square, all right? So that's basically a square 2ab plus a b square. Now I just saw it and I, completed the square. Maybe you'll need to, I don't know, you split the middle term and check whether that's happening or not. This becomes easier. I think this is probably the easiest way if you can look at it this way. Another way also to be, as I said, is you could have substituted y equals ax square, and then you'd have had an entire equation in x. I'm not sure whether it would go and how complicated, how easy it would be. If it's easy, do mention that in the comments, okay? Do mention that in the comments if there's another technique to do it other than this substituting y equals ax square or this particular technique. But I just saw that this is a perfect square, okay? So that is my the square of x square. So that term comes in there, and this is the square of 2y. The square of 2 is 4, square of y is y square, and then the middle term is 2ab. So 2 times 2 is 4, 4 times x squared times y. There you go, you got the middle term. So it looks like that. And now we have this very nice compact form, x squared plus 2y the whole square is equal to 0. That means then you have x squared plus 2y equal to 0. That actually pretty much does everything, right? So 2y is equal to negative x square. Negative x square, okay? So y should be equal to negative 1 over 2x square. And that's precisely, in the form that we want. It says, solution is y is equal to ax square, and it says find the value of a. When you compare that, you can just say therefore that a must be equal to negative 1 over 2. What we've done is that we've just used the condition that dy by dx is equal to 0, completed the square in the sense that it was in the form, it was the easiest form, I thought, algebraically. Again, algebra in this particular paper, and then, using that condition, we get y is equal to negative 1 over 2x square, giving us the value of a to be negative 1 over 2. As I said, you could have done this the other way around also, but I don't know how much time I have. Maybe do I have enough time to show the tip? I think so. It's 15 minutes down. Maybe it'll be how long. I'll just show you something very quickly on my calculator. Okay, so although this is not a calculator paper, there you go. Can you see the slope fields? This is the same differential equation. Okay, this is the same differential equation, and I'll just show you how I entered. Can I do that here? There you go. This one. Okay, this is the same differential equation. By the way, this is on the TI-Nspire 6.2, and this is the CAS version. Huh? I don't know whether it will work in the non-CAS. Let me know. This is the CAS version, as you can see, CS. But it says y1. Can you see the dash? That's for y1 prime, the derivative. Okay, y1 prime. That means everywhere here I should write y1. That's a little tip. You can't enter y. So the question actually says, in this particular question we have x to the power of 4 plus 4x square y. Okay, but that y corresponds to that dy by dx. Is that right? That y corresponds to the dy by dx. So in the calculator where it says y1 prime for dy by dx, the corresponding y1 should be there on the right hand side. Okay, I hope that makes sense. That's why I've entered it as this is y1 prime. Okay, don't forget this is y1 prime. Okay, and so the corresponding y term is y1, and this is the initial condition. This is the initial condition. The initial condition here is 0, 0. So the curve that you see right now, this is a solution curve, not the solution curve that we drew. Our initial condition was something else. So if I were to put the initial condition here, if I go and I think the initial condition given in the question was 0, 1. So if I just go and change that to 0, 1, guess what? The solution curve will change. Why am I showing this? Why am I showing this? Because you know what? There you go. Can you see this? Can you see this? Okay, this looks like our solution, right? This is 0, 1. This looks like our solution, but it goes here also because our window setting was right up to 1 point, as I said. No? Can you come back? Can we come back? Our window settings here was not more than 1.5 up on the y-axis, which is one of the first comments I made, right? So when you come up here, you can see that this is going up till 3, and that's why you can see it going here. Okay, so why am I showing this? Because you know what? In both the calculators, whether it's a Casio or the TI, this feature is not allowed. Okay, in the exam mode, in the press to test mode, the exam mode, this feature is not allowed. But the reason I'm showing this is because it's a good way to see the solution before. When you're learning, when you're studying, you know, it's a good way to see, because then you'll get an idea, oh, this is how it should be. Because many times when you learn, it's good to see the solution first, what it looks like, how is the solution behaving. Oh, if the initial condition was this, what would it be? You know, you see how I changed the initial condition. So what happens is, a good tip is that if you have a calculator such as this, let me know in the comments if it works in the non-CAS also, okay? Because I'm using a CAS version. But definitely in the press to test mode, this feature will be turned off. Okay, you will not be able to use differential equation graphing. Okay, otherwise this question will be just easily knocked off. Okay, but as I said, use it to study. Maybe we'll do another video. Okay, if you'd like that, do mention in the comments. I think that's all the time that we have for this particular video. If you found anything useful in this video at all, please make sure that you like, share this video with someone, and subscribe to my channel. As I said, you'll find several other videos on my channel. And if you need a topic even on differential equations, on slope fields explained, do mention that in the comments and I will make a video for you.